Welcome to Civil Projects of Onumoy. Friends, we are discussing about prestressed concrete due to it has a vast market today. Precast is not prestressed. Although the monolithic behavior of steel and concrete in reinforced concrete works proves to be an ideal combination of the two materials, yet there are certain deficiencies inherent in the combination. Since concrete is weak in tension, an RCC beam at times develops minute cracks in concrete on tension side of the beam, even when the stress developed in tensile steel is much less than its permissible value. The formation of minor crack, however, does not in any way endanger the stability of the structure. It is observed that the amount of cracking is nearly proportional to the stress developed in steel. Hence, high tensile strength steel, if used in RCC works, cannot be subjected to its full stresses because it will result in the formation of numerous wider cracks, which may lead to the corrosion of reinforcement due to atmospheric moisture and hence may affect the stability of the member. It is therefore obvious that the use of high strength steel in the conventional RCC works may not always prove to be economical. With the introduction of the concept of prestressing, it has become possible to avoid the formation of cracks in tension concrete and to use high strength steel most economically. The essence of prestressing a concrete member consists in the induction of sufficient compressive stress in concrete prior to the member being subjected to loads, live or dead loads, in the zones which will be tensile when the loads are applied. Thus, when the prestressed concrete member is subjected to external loads, the already induced compressive stress in concrete will be neutralized. The tensile stresses develop in the member on loading. Hence, the resultant stresses in concrete in tensile zone will be eliminated altogether and get reduced to a great extent. In pretensioned method of prestressing, the reinforcement or tendons are placed on the casting bed in the design pattern. Then they are tensioned to the required limit and fixed with the anchor posts provided at each end of the casting bed. After this, the formwork is erected around the tension tendons and other reinforcements, distribution bars or stirrups, etc., are suitably placed in position. Concrete is then poured in the prepared formwork and is consolidated and cured. After the concrete gets fully hardened and develop the desired strength, the connection between tendons and the anchor post are released. On account of the bond between steel and concrete, the tensioned tendons, as they try to shorten, transfer the induced force to the concrete, thereby compressing the hardened concrete in the member. Thus, the member gets prestressed. Finally, the lengths of tendon projecting on either side of the member are cut and the prestressed member is removed and stored for onward transportation to the site of works. In some cases, depending upon the quality of steel and the diameter of the wire used, the bond between the steel and concrete may not alone be sufficient to prevent the tendons from returning to their original position after the concrete has set. In such cases, special anchorage treatment is necessary to be provided at the end of the member. This method is commonly adopted for prestressing simply supported slabs, beams, fence posts, etc. For the post-tensioned member, the procedure of precasting is the same in all the systems except that the details of the tendon and method of providing anchorage differ. In almost all the important systems, the cables and the hydraulic jacks used for stretching the cables, that means tendons, are specially designed to perform the job of prestressing. In Freycinet system, a Freycinet cable is composed of a number of parallel wires. The wires of each cable form a ring in cross section and are kept in position by a helical spring. The cable is pushed into a flexible metal tube or sheathing prior of laying it in the formwork of the member to be concreted. The cable projects about 600 to 750 beyond the ends of the metallic tube to enable the tensioning jack have a grip of stretching the cable. The cable assembly is then placed in the already prepared formwork for the member and tied in position exactly in the same manner as is done for the reinforcement in RCC members. The anchor fittings used in Freycinet system consist of two parts, the female cone and the male cone. The female cone is a precast reinforced concrete cylinder having an axial taper hole which is lined with a close spiral of high tensile steel wire of about 11 SWG. The main reinforcement of the cone consists of a triple helix of 4 SWG wire. The male cone is a precast reinforced concrete conical plug cast round a steel tube. The female cones are threaded over the cables at each end and are attached to the inside face of the end shuttering of the member. When concrete is poured in the formwork, the female cones get embedded in the concrete and on account of their corrugated outer surface, they get well bonded with the poured concrete when the member is cured and hardened. After the concrete sets and attains required strength, the tendons are tensioned by using Freycinet jacking unit. The jacking unit is placed at the tensioning end of the member and the cable wires are passed through the grooves and gripped by the wedges on the main piston. The pump of the jacking unit is then operated which moves the piston and since the wire are gripped to the pistons, they get stressed. When the wires have been stressed to the required limit, the male cone is driven inside the female cone by operating the inner piston. Thus, the tensioned cable are firmly held in position. Thereafter, the jacking unit is removed for use to stretch the other cables. Cement grout is then injected through the narrow pipe sleeve in the male cone to fill the annular space between the metallic tube and the cable completely. The operation is shown in this picture. Finally, the projecting wires are cut off and the end of the anchorage grouted to protect the steel from corrosion due to atmospheric effect. This picture shows the finished state of the end of the member after prestressing. In Monjil-Blatam system, cable ducts are first formed in the body of the concrete member by means of extractable rubber coats and the cables prefabricated usually with 8 wires each and then passed through the ducts. Metallic spacer blocks hold the cables in the designed position. Cast steel distribution plates are cemented at each end of the precast member. In Mangal-Blatam system, The anchorage consists of steel plates called sandwich plates with two trapezoidal grooves in the upper surface and two in the lower. Each group can hold two wires and the wires are held in position by a steel wedge which fits in the slot. Here, the isometric view of sandwich plate is shown. With the help of tensioning equipment, one pair of wire is tensioned at a time. When the wires have been tensioned to the desired limit, the steel wedge is driven home inside the groove which holds the two wires firmly in position. Thus, the anchorage assembly transferred the prestressing force to the precast concrete member through the cast steel distribution plate interposed between the anchorage assembly and the end face of the member at each end. In Lee-Mac-Call or stress steel system, prestressing, a rod of high tensile alloy steel is used to act as a single tendon. The diameter of the bars varies from 12 mm to 28 mm and it is thread at both the ends. In normal practice, when bar is required to be bonded with concrete, it is inserted into a flexible rubber tubing and suitably placed and tied in position in the formwork of the member to be concreted. Concrete is poured in the formwork and after it has hardened and acquired required strength, the rubber tube is withdrawn. Bearing plates perforated with one hole for each rod are provided at each end. A standard bearing plate can accommodate 1 to 3 bars. One nut is screwed on each end of the bar after inserting washer between the nuts and the end plates. For pre-stressing, the hydraulic jack is attached by means of a cotter to a slotted adapter screwed temporarily into the threaded end of the bar. When the length of the member to be precast is small and the pre-stressing force to be induced is not much, jacking may be done at one end only. For longer members and for greater magnitude of pre-stressing force, one jack is used at each end of the bar for tensioning. After the rod is stressed to the required length, the nuts are tightened against the washer and the steel plates. In an alternative method, the waist type anchor fitting are attached to the end of the bar. In this case, the bar does not have any threads. After the bar has been elongated to the required length, split metallic wedges are driven inside the tapered hole provided in the bearing plates at each end. When the jacking unit is withdrawn, the wedges grip the straight bar firmly inside the bearing plates at each end. It is noted that the prestressing force induced in a member does not remain constant. On the other hand, it decreases with the passage of time on account of variety of different causes. The cumulative effect of all such losses may be as high as 15 to 20% of the initial prestressing force. The designer should have a clear idea of the allowance to be made for all types of important causes of loss while determining the tensioning force with which the tendons have to be stressed. It is therefore apparent that the effective prestressing force acting on a section will be equal to the prestressing force actually applied to the concrete or prestressing force at transfer minus the sum of the maximum possible losses of prestress which can be caused by various factors. By the method of prestressing, it is possible to take full advantage of high compressive strength of concrete and high tensile strength of the steel used, and hence the combination of the two material results in most economical sections. On account of its higher strength, it can be safely recommended for structures having longer spans and subjected to heavy loads and those subjected to impact and vibrations. Since it is possible to eliminate the formation of cracks in prestressed concrete members, they have increased resistance to atmospheric and other chemical actions and hence they prove more durable. Prestressed concrete members are thinner in section and hence there is a great reduction of the self weight of the structure which ultimately affects economy in the cost of foundations. The pre-compression or pre-stressing induced in the concrete member lend to reduce the diagonal tension and also the use of curved tendons help to a great extent to contribute to the shear strength of a prestressed member. Hence, for a given amount of external shear to which the section is liable to be subjected to, it is possible to use a smaller section of the member. Thus, we have to adopt this method in maximum cases to eliminate cracks in concrete work, economical point of view, and to make the scope of work. Thanks for watching. If you like my video, then please like, comment, share and subscribe.